I learned a little bit more about how artificial intelligence works, and I found it pretty interesting that it's actually simpler than it looks. Uh, it's pretty much a process that could be very closely related to evolution. Think about it. You, well, it's pretty much try and error. You try, or in case nature tries. Well, look at this doesn't work, so it dies, and something that does work prevails. That's kind of harsh, but it's pretty much what an artificial intelligence does. That's why if you ever seen something, for example, a cold-blooded video talking about artificial intelligence, you see he talks about generations. That's pretty much it. It's a better AI, though it's the same AI, just with the knowledge of the past AI. It's just like the Avatar. You have the all the knowledge of the past AI, so you can try and try to do it better. And well, we have quite a show for you because, like any good presentator would do, I made a PowerPoint explanation trying to explain my point. So, well, let's explain. Well, firstly, we have pretty much what are no paths. Now, let me explain first. You can see those little things um, here. Those you can't see my actual mouse. I think I click here. Oh yeah, I can. So you can see here that we have those nodes. This is called nodes. This pretty much are my states, for example, from the last video. And of course, remember to watch my last video so you understand what are the more technical terms like states. Which, if you want a quick rundown, what it is, a state is pretty much a frame of time of information of values. So just like a game save. So if you save a game, it would save your time, your score, your character. That's pretty much what a state is, just with the actual information of the artificial intelligence here. So we have this pretty simple. We have some nodes, and let's say here we want to go to node E. Now there's a quick set of instructions. This specific way of trying to find solution works. Well, firstly, I will start with the frontier, which the frontier pretty much means that, well, it pretty much means that the connection I have with the actual node I'm working from to the what I can go to. So pretty much meaning that the frontier is my possible outcome or my possible connection, which in this case is B. So I have a little bit of a loop here, which the computer will try to follow. Um, well, if my frontier is empty, then there is no solution. Since it's empty, there is no solution. So, well, here there is nothing here. So I can jump this stage. So, well, that means that I need to remove a node from the frontier. I don't have any node from the frontier, so I don't need to remove it. If a node contains a goal state, return the solution. Since A is not my goal state is E, then that's also not apply. So I expand a node and add resulting nodes to the frontier. Expanding pretty much meaning the connection. So in this case, the only thing this A is connected to is B. So I will, well, go to it. And so we try to, well, we would try to connect with dots. So everything that, for example, here A is connected, which is just B, will be added to the frontier. And since it's now added to the frontier, and again I go to these steps and resulting node to the frontier. So if the frontier is empty now, there's no solution. It is not, so okay. There might be a solution here. So I need to remove from the frontier. And by removing, I'm effectively turning B into my next goal. Or no, sorry, not my goal, sorry. but into the node N. Okay, so I will stop to look at A, and now I will look at B. So I will run the same thought process here. If my frontier is empty, no solution. Okay, I know that. So there is no solution here. I remove a node from the frontier. I just remove it. So no need for that. If a node contains goal state, return the solution. Since my goal is E and not B, so well, no. So I expand a node and add the resulting nodes to the frontier. I will expand them, and now we have some nodes. In this case, 2 nodes. In the sake for simplicity, I will just go for C. So let's suppose the artificial intelligence chose the right idea and goes to C, and it will actually do the same process. Again, it will look, since there is no goal and there is no solution here, you see here not in the goal state, and I also not in the solution. That means, well, I need to expand again. So by expanding again, firstly expanding my frontier since now I know here, and secondly going to my frontier, meaning going to E, I had to reach my goal. The artificial intelligence will probably stop right here, since after all, well, if a node contains goal state, return its solution. Solution being E, or if you want to be more specific, the set of solution would be A, B, C, E. So that would be my solution. So it goes pretty much like um well, what you could say, pretty much like drawing. Pretty much when you're drawing a straight line, you probably you shouldn't stop. You just draw a big circle, for example. Unless you are, let's suppose you just draw. Let's propose for more like a train with stations, but you are blind, or for example, you have absolutely no connection and no knowledge about the roads. The train would make sense, but let's say more like car in streets. So you're running along the street, you have your house, and you want to go to the house of your friend. The only problem is there is no internet, no GPS connection, and you have absolutely no idea, and it's pitch dark. Let's remove the idea of crashing, because this is probably the first thing that will ever happen. But well, you will need to make this little checks. But now you're probably wondering, well, what happens if artificial intelligence chooses, instead of here on my frontier, instead of C, chooses D? Well, here you got a problem because you can't see, since my arrows is just going one direction. I cannot go back, meaning that I actually stuck on hard hard. It's not hard stop, but well, soft a hard reset. It's not reset. It's pretty much a hard lock. Since here there's nothing, it will check again. It will check if my frontier is empty. Yes, and then it will expand note, meaning F, and then well it goes to F. Here in F, I have no solution, but also my node is not a goal state, meaning that I won't return the solution. Here, the artificial intelligence reaches end, a dead end, and it cannot go back again since it's just one-way trip, meaning I'm stuck. And well, I should turn the artificial intelligence off. And believe it or not, from what I understand, if you do not set it specifically, which usually people do, but if you do not set it specifically to remember the nodes it took for the next try, it will just keep trying and trying, so pretty much by chance. But here's the problem. This just chance leads to a problem. You can see here, I have gone back to the node A, but I have put 2 lines. That means both directions. Now, here's one of the actual biggest problems of this specific set of solutions. I think this is probably the most common, or sorry, the most easy way to set up artificial intelligence. Now, here's the problem. If you do not make the such as artificial intelligence remembers where it goes, That means that, well, it's by pure chance. It could choose, let's see, for example, here again, it could choose, it could choose C, it could choose D. But this becomes even a greater problem when we're talking about both directions. Because, well, again, if I go again, the artificial intelligence will see, well, my frontier here is B. Okay, that's fair. That's my next goal. That's my next node that you can interact with. And since it's not a goal, neither a solution, then I will go to B. But here's where the big problem stands. From B, my frontiers are A, C, and D. That meaning that, well, I have a lot of frontiers. But there happens. Here is the big problem. Since A is the frontier and I'm not connecting as saying, for example, here that it needs to remember, it could simply go back to A. And, well, we know that going back to A means that we are effectively in a loop. After all, it would then say, well, my next frontier is B. And it could potentially get stuck here forever, or for thousands of years if you know no human interaction. By just going A B A B A B A B A B, it could possibly be stuck here forever, or it could take a long time to resolve itself. Again, considering we do not take such measures against it. After all, it probably should be a good idea to put, well, remember the node you already visit. After all, something like this could happen, especially in two-way nodes. And if you try again, for example, again in the situation where node B is connected to C and D, and it fails, it goes to D, and there is a dead end. It should probably remember it would be pretty much I would say a no-brainer, but more like a very good idea. So the artificial intelligence can remember what happened when it goes to D, and it does not. It ends into that end. So that's a little bit here. Now, there is a solution for this problem, but the solution I will be talking about tomorrow, since it's pretty much another method. Alright. So, well, I hope you liked this video. And if you did, subscribe to the channel and hit the notification. After all, this will make so that when I release my next video talking about the next resolution, you don't need to go to my channel. YouTube will just remember you. Not just that, but if you like this video specifically, like this video, and of course check my social medias out there. Also, this course is a course from Harvard, which is really cool. It's from the AID, of course, and from Harvard. The course is free, but I'm not sure if you can already get it. For what I know, it probably has the encryption closed. But I think that's it. If you like it, again, like and subscribe, and I see you tomorrow. Bye!